In this video, I'll be documenting the process of me creating a test joint. The reason why I'm doing this is because I need to test how well my joints fit together, and it's better just to make a small representation of a joint than to print the whole thing. And luckily, the printing process for SOLIDWORKS is pretty simple. It's built right in, and I'll show that in a bit. You can search for the 3D print function in the upper right search box, and then you just select the file type you want and then you print it. It's pretty simple and it works well, seemingly. I haven't had any issues with the files, so it's what I'm going to be sticking with. So the 3D printer at the library that I'm going to be using is a Pruda, so it needs a Pruda software slicing program, and so I just installed it on my computer so that I could estimate my print times and just kind of mess with the settings beforehand, so I don't have to waste a lot of time at the library and I can just spend it all on printing. When I got to the library, I opened up the software and somebody had this loaded. It was labeled Threaded Barrel Subcompact, and I'm assuming you know what it is, so I just thought that was very interesting. This is just a clip of me getting the printer ready. I have to select the PLA so that it knows what it's printing, so that it preheats the nozzle accordingly. And the next what you're going to see is the printer setting its bounds. I think either it does it with limit switches or just by an increase in current in order to power the motor, and when it hits a certain amount of current, it realizes that it's hit the end. And this is just a short time lapse of me doing the print. So as you can see here, I'm just trying to fit the joint together. It's a bit rough because it hasn't been used yet, so there's some bits and pieces that need to be knocked out, but as you'll see shortly, it doesn't come together fully, and it didn't matter that I tried really hard. There's still just a bit of a lip on the top, and I'm gonna have to change that in the settings. So I'm just weighing my print right here. It comes out to 7 grams, which is about 70 cents because it's 10 cents per gram, which is pretty sure at cost for the material. So at home, I was taking a look and I pushed it together even harder than I did at the library, and it finally snapped. You can see it delaminated right here, and what that's going to mean is there's just too much friction in between the joints. So I'm going to change the taper angle for the male part. No, I'm going to change the taper angle for the female part. The male is at a 2-degree taper and the female part is at a 1.9 degree taper, so I'm probably going to change it to a 1.5, or I'm just going to do a series of prints just to see what works best.